All right, well, welcome to Coordinate Geometry Video 1. These are going to be a series of very short videos because some of this information you've seen before. Now, the difference from this year, from previous years, is that we're going to be finding the distance between 2 points and the midpoint between a couple of points, not only in 2 dimensions, which is x and y, but in 3 dimensions, which is x, y, and z. So that's actually going to be sitting in space, not just sitting flat against your page. But you're going to see it's not that challenging because, in fact, the equations that you're used to seeing just simply get a little bit longer. All right, so we're going to find the distance between 2 points. First thing we need to know is that we need to use this equation here, and it's probably very familiar to you. It is a version of Pythagoras. If you remember with Pythagoras, we know that we have h squared equals a squared plus b squared. In this case, when we have coordinate geometry, the length, we're actually going to shorten this. So if I said h equals the root of a squared plus b squared, you will see that we work out the distance using x2 minus x1 and y2 minus y1 between 2 points. So you've got 2 points in space. So what we do is we look at the difference between the x's, which is here. So that's x2 and this is x1. So if we take x2 minus x1, we get this length. That's that a distance, this one here. And then for the vertical, we do the same thing, but this is y2 and y1. Okay, and so we find the difference between those two, and that gives us this b length, or the second length of this. Can you see the right angle triangle here? Okay, so here's the beautiful formula. You are given it, so don't panic. The first thing to do, though, is to be very, very careful with labeling. So we've got 2 coordinates here. You're going to see I'm going to label them x1, y1, and x2, y2. That means this is coordinate xy number 1 and coordinate xy number 2, and I'm going to be extremely careful to label them before I insert them into the equation. Now, if you have a look, I've very carefully done this. Okay, so let me just show you here. So it's x2 minus x1, so you'll see I've got 10 minus 2. So there's the 10 minus 2, 10 minus 2. And then we've got y2 minus y1, so that is 15 minus 9. And there is the 15 minus 9. And I've squared both of those. Now you can run this straight through your calculator. All right, run it straight through your calculator and root it at the end. I've shown you a little bit of working here. Just, you don't have to show this, but you can if you want. So 10 minus 2 squared is 8 squared, which is 64. 15 minus 9 is 6. 6 squared is 36. Interestingly, that equals 100. I'm going to root that down, and I'm going to get 10 units. So that is saying if you have these 2 points, and you said how far is it between those 2 points, it's actually 10 units. Okay? You've done this before. The big key here is to label it. Now here's the interesting one. Now we're going to find it 2 points in space. So you'll see my coordinates now have 3 parts. They have an x, a y, and a z. So an x, a y, and a z. So if you have a look at this equation, can you see there's the bit we know already. Here's the unfamiliar bit. It's got a z part because it's saying, all right, backwards and forwards, where are we sitting? Okay, but we're going to do exactly the same as we did before. Notice I have labeled my triangles. So instead of having x and y, I've now got x, y, and z. This is number 1. This is number 2. And it's as easy as basically finding the right number in the coordinate and sticking it into the equation here. So let's see if I've done this correct. Okay, so here we go. So we're dealing with the x's first. So it's x2 minus x1. There they all are there. Okay, and then I've got y2 minus y1. There it is there. And the last one is extending it is z2 minus z1. And there it is there. Okay. So just similar, you can put this straight in your calculator if you wish to. Oh, I do apologize. That should be a 2 up high. I must have mistyped it. I do apologize for that. Okay, and then I've worked it out. So 10 minus 2 is 8 squared, 64. 15 minus 9 is 6, so 6 squared is 36. 12 minus 4 is also 8, and that squared is 64. Now again, you do not need to show this line of working. You can bung that straight through your calculator. I just did, so to check, you can check your answers. So that comes up with root of 164, which if you hopefully solve, you should get 12.8. I'm really hoping that's correct. I had to do it without a calculator, so it's a little bit scary. All right? Okay, and again, it's got units on the end. So if we have two spots in space, you're basically doing one is this way, X, Y, and then you've got a Z going backwards as well. Okay, and it's the difference between each of those three. Good work.